So after looking around at the volatility framework with my friend Victoria, which Dr. Hansen goes over here, I noticed version 2 was quite a bit outdated and found a version 3 which I wish I knew existed a while ago. Version 3 does better with Windows, Linux, Mac, and Android type memory readings and has all the dependencies baked inside. If you're familiar with Dr. Hansen's course, he goes over the malware analysis and the memory images in the course, as well as VMware images and memory dumps of traditional operating systems. If you're interested, leave a comment and I'll go over these in more detail. It is obvious to point out that using volatility is useful if you encounter ransomware, if you encounter a virus and you're not able to run any reversing tools. Kernel driver a kernel driver is encrypted or packed and you need to unpack it, and strong anti-debugging and protections applied to packed files, which does happen sometimes. And if you're familiar with a debugger, and if you would like to hear about debuggers, leave a comment. I may make a video. Here is the default thing for version 2. If you have XP Service Pack 2 32-bit, it defaults to that version 2. And here are example commands. Image info, KDBG scan, which is kernel debug scan, PS list, PS tree, these are process information, connections or internet connections, and yeah. Here's a write-up of what common plugins are. Feel free to pause the video, take a look if you're interested, because they continue. You can pause here as well. And these are using the version 2 commands. When it comes to version 3, we have from our info file standard information. These are not used for an assignment given, although it will give you specific help on a given plugin. With the plugins, we can look on banners, which attempts to identify potential Linux banners in the image. Runs and auto magics, and both prints and outputs configuration in the output directory. Interesting. Framework info, which is a plugin to list various module components of volatility. Is finfo, determines information about currently available is F files or specified one. Layer writer writes about layers by a stacker. And in Linux, it's right out here. Linux bash recovers bash command histories from memory. This is the bash history file. check a info, which verifies if a function pointers is to a network protocol. Credentials check. You can read the rest. Pause if you want to get more details, and leave a comment regarding the Linux and Mac stuff if you are interested in hearing more. Although I will say Mac bash is deprecated because Mac moved to ZSH 2 years ago, and a lot of modern Linux systems also use ZSH, so might be worth to take a look if they do ZSH or bash. Here we have a timeliner. Yeah. But what's really interesting is how the plugin name changes. So you have Windows Big Polls, which is a big page of pools. Cache dump, which dumps cache from memory. Callback is a list of kernel callbacks and notification. Command line lists process command line arguments. Crash info is an administrative info collection for crashing. Device tree is basically device manager, but seen from the registry. DLL list is the linked modules. DLL is dynamic loaded link, and this will show every DLL associated with a program. Driver IRP is the interrupts of device drivers. Driver scan is what drivers are running. This is particularly important if you want to know if there's some weird hardware going on. Dump files dumps cache files from the sample memories. Environment variables sees if somebody modified it. File scan will scan for file objects in the memory. Get services SID. This will list all services running. This get SID prints the SID zoning each process. Handles list processes open handles. Hash dump. This will get passwords from Windows. Info, which in version 2 was image info, shows OS and kernel detailed. LDR modules are list of whatever LDR modules are. LSA dump is LSA's mal files or memory ranges that potentially contain injected code. This is good for reverse engineering. This looks for the master boot record and potential issues. This is what's in memory. This looks for MST files. This looks for running modules. These are loaded kernel modules active in memory. Looks for mutexes, network objects, network using memory, full scans, process token privileges like who's logged in, active processes, looks for a particular process name, does a hierarchy tree of the process. This is internet certificates, which would let you know if somebody's on a particularly interesting site. These are registry hives, and this search is a better output. Print key lists registry keys under a hive under a specific value. This is user assist key information. List processes with session information. Sessions from environment. Skeleton key malware. That would be interesting. STD is standard system calls. Statistics. Strings are strings in memory. Scan Windows services. Look for system links present. This again could be virus or nefarious stuff. Processes in a memory range. All memory address using Yara, which is malware scanner. Lists version information from PE files. Lists virtually mapped sections, and Yara scan. So let's take a look at this using system info. Windows.info.info, and it will read through all these commands. While it does that, I will point out that this is analogous to image info. And we get a dump. It says 64-bit, there's no PA file. This was on an Intel machine. fire labeler, NT build, kernel data block, number of processors, date created, where the root file system is, what type of operating system it is, what version of Windows is, what minor version, some PE information. One thing to realize is this does not have profiles. It will extract the profile on its own. Not all of... I cannot find full analogs to some of these, like kdebug scan, but we don't have profiles. So we go with, let's do a PS list. Windows PS list.p list. And it shoots out all the running commands in this column. The image name with the PID here and the PPID here. Next up is PS tree, and this will show you what things are dependent of. As you can tell, Explorer.exe is the parent to VMware tools, Notepad, and Command Prompt. Next up is on the list was DLL list. I believe that's the command. This loads all the DLLs that are featured in the image. It gives you the location, where in memory they are, and if they're running, and the common name. And it breaks them down by process on the left side, as you can tell with the VM tools. Let's go up to the top here. Oh, this is good. This image was taken from a virtual machine. Next up, I believe, is consoles. Let's see, what is the analogous? I think the closest is command line for that. So Windows.cm line, cmd line. Nope, that is not the closest. Let's try strings. We have no strings file. Nope, but next up is connections, which is under a different name. I think it's netscan. Could also look at netscat. Netstat also shows nothing. There is no sockets option, so let's do Hive scan. And there's also Hive list, which shows better information. Next up on the list was SCV scan, which there is a one-to-one module for. And this outputs a registry, or services, rather. We have up on next on the list is command scan, which I also don't see in there. We did net scan. There's Yara scan. Yara scan. Seems I may have typed that wrong. Yara rules would need to be implemented. That is beyond the scope of this discussion. Next up on the list is get SIDs, which was in here. And these are all the SIDs with the command and the strings associated with them, I believe. Next on the list is hash dump, which I spelled. And this is the users with a Windows 10 hash. However, these will need to be concatenated correctly with the colons if you're going to run them through a parser to crack that password. There is LSA dump, which again I spelt wrong, because apparently I think dump needs to be capitalized, and that's not useful. Next on the list is memmap, so I'll just copy that there, because I would capitalize memmap. And this is listing all the memory. On the slides from Dr. Hansen, the next object is reg-ob keys, which are a list of open registry keys. But we have certificates, which are technically open keys. And these are expected certificates on a default Windows install. Let's see what print key does. These appear to be the open registry keys. Let's look at some other ones I'm not sure about. This being the file scan, which shows nothing. See the dump files. Those won't be anything interesting. These are the environment variables. They look very standard. That doesn't look interesting either. Let's see what sessions is. That's unremarkable. That's unremarkable. Man, consoles is different. So we know Notepad is open. I ran my search and I found Notepad here, Notepad referenced here, Notepad referenced here. I believe that's it. I also ran the search on text within the Notepad that I know about. This file doesn't coincide with any of the text, nor does this, but this one does, and it gives a file name. If you search the file name in the dumps for the Notepad process, since we're in Explorer, you can find the secret message within that. So to do a memory dump, let's look at vedinfo.h, and it says you can take a process ID and do a dump. So we will take the process ID for Notepad, which is 1596, and dump it. I already did that and placed it into a bads folder. This contains all of Notepad, and we can then do a search for a string found within the Notepad file that we're looking for. We notice that the Notepad had a secrets, so what we can do is run this command. Should pause it to look at it, and this will pull up every instance of the word secret within a given file. So for this file here, it has secret set a few times, as with this file here, this file here, and this file here. Viewing what the secret message is left up to the user.